Hello everyone. So today is July 22nd. Okay. So in this video I am going to speak about the concept of caching and also the concurrent transaction in DBMS. Let's get started. First we need to understand what is caching. Actually, caching allows you to efficiently reuse previously retrieved or computed data. Caching is a high-speed data storage layer which stores a subset of data, typically transient in nature, so that the future requests for that data are served faster than is possible by accessing the data primary storage location. For example, as you are able to see a diagram over here, this is our data means this is our DB, this is our application, and application is requesting for certain data. So what will happen? In the current scenario, it will go to the DB, it will get the response, and okay, that's all what's it doing right now. But actually in caching we add a caching means it's a kind of DB only, in which the previously retrieved info is stored for a certain period of time. Okay, so that's what caching means. Then we will first check in the caching that whether the data is present over there or not. If present, then we will take that data, and we will give means proceed it as an response. So that's what called as cache hit, means you found the info in the cache and you took and send it as a response. But if in a scenario where the in the cache there was no data present, then what will happen? It will go to the DB and get that data which will be stored in the cache and then return. Okay, that's what cache mean. So that's the concept cache means. Okay, then moving forward, we could implement caching in three layers. First is the DNS, second web, third the application. The DNS actually is associated with the IP. How it means how it works. Wait a second. So the request which are coming from the same domain, actually as you are able to see over here, caching these results mean the repeated request for the same domain are resolved faster. With the help of DNS, uh, you could work on the requests which are coming from the same domain, which could be resolved faster. So that's what DNS means, and it's beneficial for reducing latency and enhancing user experience by avoiding delays in domain resolution. Okay, then the next is the web. Actually, web is used to access the images or web pages and other content easily. So what happens when we are actually frequently calling? Okay, uh, when user request content, the cache delivers it quickly without needing to retrieve it from the origin server, which reduces load time and server strain. Okay, and it is actually done with the help of CDN. So that's what the web caching means. Then the next is the application. Actually we are going to learn about the application caching in our further in this video only. So we are primarily focusing on the application. Okay, in the application, caching improve performance by storing frequently accessed data and computational result closer to the application. This reduces the need for repetitive and time consuming database query or complex calculation. It is implemented with the help of Redis. Okay, Redis is actually a good DB or DB for caching purpose. Okay, it's also good if we implement in our application, but it's a little bit costly. Okay, so then the benefits of caching: it makes data access faster, less expensive, improves the performance of the application, gives response quickly. Data access from memory is always faster than fetching the database. It reduces the costly backend request. Then the caching terminologies: we talked about caching hit. When we get the data from cache miss means we do not have the data present in the cache. Eviction policies means actually these eviction policies are also really helpful. in the caching, as the LRU stands for least recent. Okay, then the LFU least frequently, the least recent, least frequently, first in first out, and the TTL stands for time to live. Okay, then it's also very useful that we will see in this video only, in the next part, how we can implement it. Then loading strategies as well: lazy, eager loading, cache warming, and size and capacity. Okay, so this was about the introduction to the caching. We will move ahead. Okay, the default caching. So the Spring Boot has a caching inbuilt. So what we need to do, we need to actually enable the caching. I will show you the code for it in the config. Okay, in the cache config, what I have done, I have created a class and then enabled the enable caching on it. So with the help of it, we could be able to implement it. Okay, the enable caching, it's a class level annotation to enable caching in Spring Boot application. We do not need to add any kind of dependency for it. By default, it set up a cache manager. It sets up a cache manager and creates in-memory cache using one concurrent hash map. Okay, then the second is the cacheable. It is a method level annotation. It is used in the method whose response is to be cached. The Spring Boot manages the request and response of this method to the cache that is specified in the annotation attribute. Okay, so we could understand. So this was the class level annotation. Now we will move to the also the caching is added in the service layer. Okay, so in the service layer, in the auth, actually I have added the caching over here, as you are able to see. If you go over here, no, wait a second, I will show you later. So this is the cacheable. So what does cacheable do? It's a method level annotation, and when you put it on a method, the response of it will be stored, the response of that method will be stored in the cache. Okay, so we, as I told, we have an in-memory cache manager. We will see the cache manager. Okay, the cache manager over here has various sort of implementation. Okay, it also has the Redis cache manager. So as it is an in-memory, so the cache will be stored in the in-memory. So this is the pattern to write it, where we give the cache name, then the key for it. Okay, over here, as you are able to see, if you are passing any sort of ID, then you could do one thing, that it will return a result.id, which will be then stored in the cache. Okay, then if you want to pass two things, then you could do with the help of this also. So this was about the cacheable. Now we will move ahead. Moving ahead, what will happen? What will happen when you actually update? Okay, so cache put is really helpful over there. What will happen if you are updating an employee? You update its detail, but the updated employee should be put in the cache. But if you implement it with the help of cacheable, that's not going to happen over there. So we need to put the cache put over there. It's actually helpful for the put request. It's also a method level annotation. It is used to update the cache after invoking the method. By doing this, the result is put in the cache. After the method is executed, what sort of result, the result will be then put into the cache. Okay, so this could be done with the help of cache put. Then cache evict, it's helpful when you're deleting some sort of thing. So if you delete something, that also need to be, the response need to be over there. For example, it's also method level annotation. Then it is used to remove the data from the cache. Okay, when the method is annotated with this annotation, then the method is executed and cache will be removed. Means if in the cache there is an user with id 5, but you have actually deleted it, then it should be deleted from the cache as well. So that for that purpose, we could add the cache evict in that. Okay, so we will also understand the internal working. So as I told you, we have a cacheable class, cacheable, which is put on the method. So it's intercepts the spring AOP, the call, and checks the cache before executing the method. Then we have a cache manager is called to retrieve the cache associated with the given name. Then, as I told earlier, cache hit, cache miss, I will not speak about it right now. Then it's actually the flow of its working. Okay, we have a cacheable class, we put it on the method. Then the response it calls the cache manager, it retrieves the cache data and put it in the cache. But there could be two possibility, either it will hit or miss. If it hits, return it. If it misses, then put the data in it. Yeah, cache was missed, then the method executes, the result is stored in the cache. But if not, it is finally the result is returned to the caller. Okay, so that's what about internal working. It's not really hard to understand caching. Okay, let me see if any other code was remaining in the auth service. Okay. Okay, then the next thing is Redis cache. Now, how could we implement the Redis cache? Okay, so for it we need to actually have if you are in the Windows, you need to have the WSL. So I have Ubuntu in my system. Okay, let me show you. I have Ubuntu in my system, and in the Ubuntu we actually need to download, first update the packages, then we need to download the Redis. Okay, so the steps for you could get the steps for it from the chat GPT as well, how you need to do that. But I will actually show you the, wait, give a minute. Over here, actually I will do one thing, that I will actually run it. Okay, it's asking for my password. Okay, now we will see the status for it. Status. So as you are able to see, currently our Redis server is running right now. Okay, and if we want to see the CLI, we could see we are able to get the response from the CLI as well. So we now know that the Redis server has started. Okay, now we need to configure it with our system. So first thing, we need to add the dependency of the Redis. Then we need to add the configurations. So I have added the configurations in the YML file. So data, Redis, host, port, password. Okay, so we will add the ignore this right now, as it's the means the host which I was using, that was the cloud. We will talk about the cloud in the means in some time. So if you have the local host, then you need to add the local host over here. It contains the IP as well, if you are able to see over here. So this is the IP 6379. You need to add the local host, then the password for your local host, as the local host does not require any sort of password. Okay, then you run it, then the data will actually send to your Redis, which is on your local host. Okay, the configurations. So these are the configurations: type, host, port, password, SSL. Okay, we also have an Redis cache manager, as I showed you earlier. If we get the cache manager, in the cache manager also have the implementation for Redis cache manager. Okay, it has certain things. We could also configure Redis as per our requirement. So see, the cache manager interface implements this Redis cache manager. It has various methods, but we could do one more thing. I want to show you that the cache manager, I have actually in the cache config, what I have done, I have created a bean for the cache manager, and we could also tell how it should work. Okay, so what I have done over here, I have actually passed the Redis connection factory. Okay, for the configuration, I have added the cache name. So the prefix for the cache name should be this. You can add as per your need. Then the entry TTL. When it enters, when any sort of cache is added to a system, how much time it should exist. So we have added the time to live for it. Then the next thing is, if a user calls the request again, the time for the TTL time would not be affected if we don't add the enable time to idle. If we add enable time to idle, then what will happen when we will add the cache, when we will request the cache again, then from that cache the time will reset for the TTL. Okay, so that's what happens. So this was the Redis means cache manager which we have set as per our need, and then for it, okay, so we have to configure it here, then actually it will run. Okay, then moving on to the next thing, that is the concurrent transaction management. First we need to see the transaction. Okay, first we will see the transaction. No, actually we need to see the basics of the transaction. Wait a second. I also want to show you one thing, that is this is the Redis actually cloud which I was using for my project. You could also implement it. It's really easy to implement. Just you need to download the Redis inside, and then you can see the request over in the cache manager which I have created. Okay, then the next thing was actually to show you, I have shown the connection enable time. And if you want to see the answer in means in the Redis insight, you want to see the actual data, what was it, then you could see serialize values with new generic Jackson. Okay, then speaking about the database transaction, transaction is a logical unit that generally includes several low level steps. One step, if one step fails, the transaction fails. The whole transaction is used to create, update and retrieve the data. Okay, so it's always reliable and consistent state. Then there are two things which we need to understand: the commit and the rollback. Commit means if a transaction is successful, the data in DB is updated. That's what commit. Rollback, if a transaction fails, then the updation should not be updated in the DB. It actually, if transaction fail, it rollbacks. So that's the rollback. Then the second thing we need to understand is the ACID properties. A stands for atomicity, C stands for consistency, I isolation, D durability. The atomicity means either the transaction will run successfully, or it will not run successfully, means all or nothing. Then the second thing is the consistency means uh, it should move from one valid state to another valid state. That's what consistency. Then the third, isolations mean if there are concurrent transaction, then it should behave like they are actually running in a means what we could say that concurrent transaction do not the concurrent transactions do not interfere each other, appearing as they are executing sequentially. Then the durability means ensure that once transaction is committed, the changes are permanent. Okay, transaction is committed, the changes are permanent. Okay, so that's what the ACID property means. Then there are various advantages and disadvantages of the ACID property as well. but we will now understand the concurrent transaction. Okay, over here the transaction, actually concurrent transaction, the transaction isolation is a thing. Isolation level define the degree to which a transaction must be isolated from the data modification made by any other transaction in the DB. It's also done with the help of transaction annotation. There are three problems which is actually been solved by the isolation. The first is the dirty read, repeatable, and the third phantom read. Okay, dirty read means what's happening. One, there are two transaction. The first transaction is actually updating, as you're able to see here, updating for the ID1, and the second transaction is selecting the ID1. Okay, but the data read by the transaction B is now dirty because the updated data was actually rollback. Okay, so that's what dirty read. Then non-repeatable means what's happening over here. You are accessing one thing, but you are accessing one thing in one transaction, but in the second transaction you are updating the ID. So what's happening in that case? That you are updating the value, but then and again accessing it, but the values difference is there. So for it's actually for one row, that's non-repeatable, and phantom means if it occurs for many rows. Okay, so these problems are solved with the help of isolation levels. So there are four isolation levels: read uncommitted, committed, repeatable read, and serializable. So we would see one by one. So read uncommitted means transaction can interfere, means there, if there are two transactions, the both transaction can interfere in each other. So that's the read uncommitted. Read committed means once one transaction is committed, then you could see that transactions data updated in the next transaction. Okay, repeatable read means some same data with the transaction. If both transactions are accessing the same data, then what will happen after the one transaction is completed, after that only the second transaction could do the updation on it. Okay, they could not work simultaneously. And serializable means actually it runs in a sequential manner. Okay, so Postgres has SSI, doesn't rely on strict logs but detects and aborts transaction that would lead to non-serializability. Okay, other transaction has the logs. Then moving on to the next thing, that is the transaction annotation. The transaction annotation is also implemented with the help of Spring AOP. There are three things: beginning, committing, rollback. If an error occurs, it will roll back. Committing, if everything is good, then it successfully commits. Then the next thing, it actually uses the proxy based AOP. As I have I have spoke about the proxies in the AOP's video. I would like to recap one thing, that the proxies are created and the proxies are wrapped over the beam of the means original beam, and then it is accessed through that only. Okay, then the next thing is transactional propagation, means if you want to use that only context, or you want to make a new context, so that's totally depend on you. So that's what the transactional propagation. Transactional isolation also, it's not really important. Then moving on, we have locks. Okay, locks also, the locks are actually means we also have the isolation is guaranteed, but we could also we could also implement the transaction logs. Okay, then why use transactional lock? Because transactional lock implement the mechanism needed to enforce these guarantees and prevents conflict by controlling access of data. Then we have two locks, the optimistic and pessimistic. Okay, the optimistic means you add a version. Okay, a new column, that is the version, and it while you're reading, it will check the version's value, and as per the version's value, it will either successfully run or will not run. Okay, and it also increments the version value. Then the actually we're done. Asymmetric locking means there are two things, the read and write. Read means the shared lock and the write means the exclusive lock. Shared means you could read the data from the other transaction, but in the exclusive lock you could neither read or write the other transactions data. Okay, so these are the locking mechanism. So that's all for the so that's all for the caching and concurrent transaction in DBMS. So stay tuned for next video. Thank you.